Review for Chapter 4 test, page 2. Find a cofunction with the same value as the secant of pi over 3. By definition, the secant of theta is equal to the cosecant of pi over 2 minus theta. Or if you're in degrees, this would not be 90 degrees minus theta, but we're in radians. So we just have to take pi over 2 and subtract pi over 3, and then the secant of pi over 3 would be the cosecant of pi over 2 minus pi over 3. So subtracting pi over 2 minus pi over 3, get a common denominator of 6. And 3 pi minus 2 pi is 1 pi over 6. And so the secant of pi over 3 is equivalent to the cosecant of pi over 6. Problem number 11. A building that is 24 meters tall casts a shadow 15 meters long. So I draw a picture. 24 meters tall, casts a shadow 15 meters long. Find the angle of elevation of the sun to the nearest degree. So this angle is going to represent the angle of elevation of the sun, and we have to decide, do we want to use sine, cosine, or tangent? Well, since we don't know the hypotenuse, but we know the opposite and the adjacent, TOA, we want to use tangent. So if you remember SOHCAHTOA, that tells you what you want to use in these situations. And if you have the opposite and the adjacent, you use tangent. So you set up your equation. The tangent of the angle is equal to the opposite side divided by the adjacent. So I'm going to show you how to do this in your calculator. First of all, we're going to have to be in mode degrees because it specifically said to find the angle to the nearest degree. So make sure you're in the right mode in your calculator. Very important. Hit enter. Then you can quit out of there. And then you want to hit second tangent. Okay, you're using an inverse tangent anytime you want to find a missing angle. And then you do the opposite, which is 24, divided by the adjacent, which is 15. And it gives you 57.99, but of course it said to the nearest degree. So round that to 58 degrees. Use a calculator to find the value of the acute angle theta to the nearest degree. So all we have to do is make sure we're in mode degrees in our calculator, and to find theta, we have to use the inverse cosine of this. So second cosine is the inverse cosine of 0.74132, and that gives us 42.15, but to the nearest degree, that's 42 degrees. For tangent of theta equals 1.15, I need to find the angle to the nearest degree. So once again, make sure you're in mode degrees and do second tangent. Inverse tangent is what you use to find the angle. 1.15. And then close parentheses, 48.99, which is approximately 49 degrees. All right, let P be a point at -2, -5. So just like if you were graphing on the coordinate plane, you're here, -2, -5. On the terminal side of theta, so that means you want to make this with the x-axis. And you want to find each of the 6 trigonometric functions of theta. So that would be sine, cosine, tangent, cosecant, secant, cotangent. So first you have to use the Pythagorean theorem. A squared plus b squared equals c squared to get the hypotenuse. Then once you set up the sine, cosine, and tangent, you're going to use SOHCAHTOA. So the sine is the opposite over the hypotenuse. So here's my angle made with the x-axis, opposite over hypotenuse. I have to rationalize the denominator, so I multiply by radical 29 over radical 29, and that's how I'm getting this. Then I have to ask myself, is it going to be positive or negative? Well, remember, all students take calculus. Only the tangent is positive in quadrant 3. So that's I'm going to expect that one to be positive, but these will not be. So negative here. For the cosine, I want adjacent over hypotenuse. Here's my angle, adjacent over hypotenuse. And then I rationalize the denominator and I get this, and I remember that it's negative because it's in quadrant 3. Tangent is TOA, opposite over adjacent. So here's my opposite from my angle. Here's my adjacent. Opposite over adjacent, and it was positive because tangent is positive in quadrant 3. And then the cosecant is just the reciprocal of the sine. So flip this and it will have the same sign, negative. The secant is the reciprocal of the cosine, so flip this, and of course it has the same sign, negative. And the cotangent is just the reciprocal of the tangent. Okay, to find a reference angle theta prime if theta is 17 pi over 6. So reference angles are always made with the x-axis. 17 pi over 6. That would be like if I took the unit circle and I divided it into, like this is pi, if I divide it into 6 parts along pi. So that would be 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6, 13 pi over 6, 14 pi over 6, 15 pi over 6, 16 pi over 6, 17 pi over 6. Or if you want to convert this to degrees, it might be easier to work with, and then just subtract 360 degrees in a circle, and that gives you what's left over, 150 degrees. So either way, you're going to land here. A 150 degree turn means I have 30 degrees left as my reference angle before I hit the x-axis. So basically, 30 degrees is my reference angle, and I want to convert it back to radians because I was given this in radians, so I want my answer to be in radians. So to convert 30 degrees into radians, you just have to multiply by pi over 180 degrees, and then reduce this to lowest terms. To find the exact value of the cotangent of negative pi over 3. Negative means I have a clockwise turn. Pi over 3, if it helps, think about it in terms of degrees. And think about your 30, 60, 90 triangle, where the shortest side is 1, the hypotenuse is 2, the other side is radical 3. So we're looking at a 60 degree angle, and the cotangent is the reciprocal of the tangent. So you could either think about it as cosine over sine, or you can think about it as, instead of TOA, which is what tangent is, you would use the reverse, which is the adjacent over the opposite. So at 60 degrees, you would use the adjacent side divided by the opposite. So that's going to be 1 over radical 3. Rationalize your denominator by multiplying by radical 3 over radical 3, which gives me this. And then you have to ask yourself, is it positive or negative? And you remember, all students take calculus. Well, the cosine and its reciprocal secant are the only things that are positive in this quadrant. Therefore, the cotangent must be negative. And then to find two values of theta between 0 and 2 pi that satisfy the equation, the sine of theta is radical 3 over 2. First of all, in order for the sine to be radical 3 over 2, we have to refer to our special right triangle. The sine is the opposite over the hypotenuse, so we're going opposite the 60 degree angle. So a 60 degree angle is also pi over 3. And so here's a drawing of what this looks like. Now, the sine is also positive in quadrant 2. Remember, all students take calculus. So all of them are positive in this quadrant. So since this is positive, we can be in quadrant 1. but the sine is also positive in quadrant 2, so we can also be in quadrant 2. So we're either going to have a turn of 60 degrees is our answer, which I'm going to convert to radians because it was given in radians. That's pi over 3. Or I'm going to go this much, which is 120 degrees, because there are 180 degrees in a half circle. Minus 60 gives me 120. And 120 degrees, converting it to radians, is 2 pi over 3. I'm just multiplying by pi over 180. That's all I'm doing to convert from degrees to radians. So make sure the answer is in radians, because it said that two values of theta, and this is in radians.